we go. So again, very good. So again, the point of today and next class is to, really we're not going to learn anything new. We're just going to put everything together to, by the time we're done, be able to take a formula and get a pretty good sketch of what these things look like. Things that before you really could only graph using the graphing calculator to figure out maxes, mins, but now we know the calculus tools that will help us get there. First of all, though, there are really only 4 shapes that our graphs will be made up of. Oops, that is not a well-written 4. 4 shapes. All graphs that we look at will be made up of combinations of these following 4 shapes. First shape is something like this. That is increasing and concave up. Increasing and concave up. Second shape is something like this. That is decreasing and concave up. Third shape could be something like this. That is increasing but concave down. Oh, go guess. Oh, good. Something like this. That is decreasing and concave down. All of our graphs that we look at will be made up of combinations of these 4 shapes. I guess we could have some other shapes where there's no concavity, which is really just like a line segment. We're not going to bother with those. We're going to deal with things that have first and second derivatives. So this is really the only new thing that I have to teach you today, these 4 new shapes and how to put them together. Before we actually go to look at some formulas, though, I just want to spend a little bit of time working with these shapes and figure out how we can put these ideas together. Yep. Sorry. Okay. So we're going to take a look at that packet that I just gave you titled Intro to Graphing Polynomial Functions. I would like you right now very quickly to just go plot all those points. Don't connect them, just plot them. When you're done with that, I would like you to take a look at those number lines below the graph, and I would like you to fill in the symbols. So on the F prime number line, we're going to ignore the F number line for right now. On the F prime, where F prime is positive, that means we're increasing, so put your little increasing symbol. And same with the second derivative, put your concavity symbols on there. Very good. Easily amused. Now, here's what we're going, any issues so far? This is really nothing new. There's a third number line that I've labeled F. On this number line, first of all, the tick marks are just going to come from consolidating the tick marks on the F prime and the F double prime number line. So anywhere either one of those has a tick mark, I'm going to put those over here. Then, in each of the regions, I'm just going to go through and decide which of my 4 basic shapes I'm going to have and fill in that shape. For example, before -1, my first derivative is positive, my second derivative is negative. That looks like increasing concave down. I'm going to draw a little shape that looks like that. In the next region, I am decreasing concave down, so I'm going to draw one of those. Between 1 and 2, I am decreasing concave up, so one of these shapes. And from 2 on, I'm increasing concave up, so one of those. And I'm now ready to put the graph together. Here's the idea. First of all, notice when I drew my number lines, I made the tick marks match up with the tick marks on the graph. I think when you go to do this, it's going to be very, very helpful if you do that. I now need to go and take on these shapes, and I also need to just kind of make sure I'm dealing with the points that are already on. They're sort of as anchor points, just things I'm going to go through as I go to draw my graph. I need to start by being concave down increasing until I get to this point. Well, I want to go through the x-intercept as well, just some other random points I'm going to go through. So I'm going to start with a shape like this. Increasing, but concave down. I am then going to curve around and become decreasing concave down until I get to x equals 1. So this y-intercept, again, is just a random point that I'm going to go through. We won't always have those, but when we do, we might as well use them. So I'm going to go through like this. Decreasing concave down. I'm then going to become decreasing concave up, so I need to change into this sort of shape. There was a point of inflection over there at -1, 0. And I'm going to end by being increasing concave up. And my graph looks like that. Nod your head if you're with me so far. Are there any questions so far? Here's what I want on the next page. Plot the points. Fill in your number lines, including the top number line. Maybe hold off on the graphing part, and we'll do that one together. 2 is definitely a little more involved. Done. Take a look at the screen. My first number line is up there. I haven't graphed it yet. I want to talk through the graph together. Any questions or issues with my number lines? So here we go. First of all, where should I start? Should I start up high, down low?
Middle, slow.
So funny. Why are you saying that, Kevin?
Because it's decreasing and it's concave up.
That's the only way I can get this sort of shape, and end up at this point over here. So I'm going to be decreasing concave up like that. Then I need to be increasing concave up until I reach my point of inflection over there. Oh, you know what? See if you can finish this.
Yes, yeah.
Increasing concave down. I'm going to do one of those. I didn't tell you the x-intercepts. Sometimes we'll have them, sometimes we won't. Doesn't matter. Just cross wherever to get to this point. And I want to do one of these. And then I want to do one of those. Is that okay? One more. We're going to skip number 3. I don't have the time for that one. But I want you to look at number 4 because you're going to have one like this in the homework. They gave you the information in a table. I would like you to take that information, make your f prime, f double prime number lines, put it all together to get the f number line. I do see 3 y values on there, so I can get 3 points on the graph. See what you can do, and you're welcome to check in with people near you as you try this one. And I think I'm just going to make all my number lines have tick marks at 2, 4, and 6. I do want the tick marks to match with the tick marks on the graph. When you go to graph it, it's a little weird at x equals 6. But that's okay. And notice what f prime should be at x equals 6. That will also be a clue. That looking okay so far? And any issues so far? So now I need to become decreasing concave up one of these shapes. Gradually, or should there be a sharp turn there?
Sharp.
How do you know that?
It does not exist.
Because the first derivative does not exist. If it was 0 or something, that would tell us a gradual change. No, I don't have that. I have a sudden sharp turn over there. So sort of something like that. Questions on this? I believe there are two just like this one in the homework where there's no formulas. They just give you the information in a table, and you put things together to sketch them. Okay. I hope we have time for one example. Back in your notes, we are going to take a look at sketching the polynomial function f of x equals x to the third minus 6x squared plus 9x. I want to sketch that thing. First thing we're going to do, and we are only in general going to do this first step if it's easy to do. I want to try to find the x-intercepts and the y-intercepts. In general, we're not going to bother with them. But in a case like this, they're easy enough to find. So I do want to try to find x and y-intercepts. X-intercepts occur when the y-coordinate is 0, and y-intercepts occur when the x-coordinate is 0. So take a moment, and let's get some points. Hans, what are you doing with the x-intercepts? David?
Factoring.
Like, what do you mean by factoring?
So you take out an x, then you factor the x's and solve.
Good. Thinking there are two x-intercepts, 0 and 3. So we're going to say 0, 0, and 3, 0. Y-intercept isn't a big deal. 0, 0, so that one point's both an x and a y-intercept, nothing too important. Really, though, these are just going to be additional points that I'm going to want to make sure my curve goes through after I deal with the increasing, decreasing, concavity, and all of that. I would like you right now to go deal with all of your first derivative work. That's our second step. Find the first derivative, make your number line, test the regions, get coordinates of maxes and mins. Then we'll stop after that, check in, and then we'll go on to our second derivative. Remember that when you go to set it equal to 0, deal with the GCF. Also make sure you are labeling your number lines, especially since by the time we're done, we're going to have 3 different number lines in this problem, an F prime, an F double prime. Please make sure they're getting labeled, just like you hopefully did on the quiz, because that was underlined in the directions. Guess I'll find out tonight. Do you have the signs on the number line? Hopefully you have critical values at 1 and 3. What's before 1? What happens when you plug in? Positive, negative? Between 1 and 3? After 3. I've got a max at 1 comma something and a min at 3 comma something. And where does the something come from? F of x. The y values always come from the original function. When 4 is a max, 3 zeros a min. Maybe. Go on and do your second derivative work. Deal with concavity and points of inflection. When you are done, I'd like you to draw some axes and put some tick marks on them. And below, I'd like you to stack 3 number lines, F, F prime, F double prime. Copy over the number lines we have and add in an F prime number line, making your tick marks match with the tick marks on your axes, just like it was set up in that packet we did.
Added 2 shoes.
Okay.
Sorry,
So here's what I'm getting when I put it all together. Go
Hello.
away. Oh my gosh.
Who's that for?
People who aren't here.
So by the F, you just look at the other two.
I'm putting the tick marks together, 1, 2, 3, so we'll put all those together. And then before 1, increasing, concave down, increasing concave down shape. It is not the most exciting graph ever, but that is what it looks like. In theory, now we can really graph anything, assuming we can find and work with the derivatives. In the homework tonight, you're going to start by just dealing with some polynomials similar to this. And then there are going to be 2 problems where I don't even give you a formula. I just give you information in a table like we saw in number 4 in that packet. However, then, to get ready for next time, I do need you to review some pre-calc stuff. And actually, not all pre-calc stuff. Some of the stuff we did earlier in the year. Asymptotes, vertical asymptotes, horizontal asymptotes, and also slant asymptotes. So what I have for you, a couple of things. No, hold on. No, here it is. First of all, is that a stretch or a question? First of all, I have a short reading you're going to do. That will review how to find asymptotes. And please make sure you read this before you try the part of the homework that asks you to find a couple asymptotes. One, two, 3. And then let me pass out the actual problems you're going to do. You're welcome. So the whole point of that asymptote reading that I gave you is next class we're going to deal with how do we do curve sketching where there are asymptotes involved. Again, you really know all the derivative work, although those derivatives get a little bit messier. We'll deal with those tomorrow. But we also need to add in how the asymptotes change the shape of the graph a little bit in our number line.
We don't have class tomorrow.
Tomorrow means whenever I see you next. You know that. Okay, so